All right, so let's look at this number 1. And this number 1 is, this is the review for test 3. It says use end behavior. We're going to use the end behavior to describe what the graph should look like. So you have P of X equals a negative pi. There's that pi that some of you didn't like. But remember, that's just a number. It's just, you remember what pi is, anybody?
3.14.
3.14. All right, so you don't really care about any part of this except this leading term, because it gives you your degree of your polynomial and it gives you the direction that polynomial is going to go. So this polynomial has a degree of 6, so it's an even degree and it has a negative coefficient. So do you remember how the ending behavior looks on one that's even? They're either going to go, remember those parabolas, they're either going to go up or they're going to go down. Which one is it that if you have a negative exponent, which picture is it going to be?
Is it going down?
So they will give you 4 choices. A is going to be like this. B is going to be like this. C is going to be like this. And D is going to be like this. So see there, they have the 4 options. These would be the ones if your exponent was odd. And these are the ones if the exponents are even. This is odd and positive. This is odd and the coefficient's negative. This one's even and the coefficient's negative. This is even and the coefficient's positive. So you can see that we want that picture that's number C. If you forget everything that you ever knew about end behavior, you can always put it on a graph. And pi, you can either put 3.14 in, or there's a pi symbol on your calculator that you can use, and you can just graph it and see what happens. See what it looks like on the end. You're thinking about on the end. What does it look like on the end behavior? Okay, let's look at the 2. Number 2 is choose the end behavior again. So we have f of x equals negative 4.4 x to the 4th plus x to the 6th plus 0.2 x to the 7th. Now somebody tell me what you have to be careful of on this problem.
Making sure they're in order and
Right.
also adding in,
Oh no,
just making sure.
Right, that's right. If you're not careful, you'll use this term right here. Is that your leading term?
No, 0.2x to the 7th.
Because that exponent is higher, you need to rearrange this and see what it looks like. So let's do that. Let's do 0.2x to the 7th would come first, then x to the 6th, then 4.4x to the 4th. Okay? Now then, this one is your leading exponent and leading term and leading degree. So your degree is odd and your coefficient is positive. So let's see which picture it should be. We've got these up here. If it's odd, it's either got to be this one or this one. So I'm looking for the one that's odd and positive. So the ending should look like this and this. Okay? And again, they'll have 4 choices just like this, and you have to pick the one that it would be. And again, you can put it in your calculator and it'll show you the ends of it look like that. Any questions on that? Okay. Let's go to number 3. Number 3 says find the zeros. And state multiplicity. And they have f of x equals x squared minus 4 to the 3rd power. Okay. Now then, I notice that this is a difference of squares in here, or I could just set this to equal to 0 like it is. But most people did it this way. They broke that up into x plus 2, x minus 2 into linear. Those are called linear factors. And you still have that 3 out there. And this is going to be your multiplicity. Right there. These are going to have a multiplicity of 3 because that's your exponent out there. So you set each of these equal to 0 to get the zeros of the function. Add 2, you get x equals 2. Subtract 2, you get x equals negative 2. So you've got zeros of 2 and negative 2. And this is the way the answers look. I'm going to do some answers with you tonight to kind of show you what it's going to say. The first choice is plus or minus 4. See how they're using that 4 up there? Plus or minus 4, each of multiplicity 6, because they think you might have multiplied those exponents. But you don't do that. You take this 3 out here as your multiplicity. B is plus or minus 2, each of multiplicity 3. C is plus or minus 2, each of multiplicity 6. And D is plus or minus 4, each of multiplicity 3. So which answer do we want?
B.
Mm-hmm. That's the one we want. That gives us the 2 and the negative 2, and our multiplicity is 3. Any questions on that? Okay. Let's go to the next one. The next one, I can get it in here. The next one is number 4. It is find the zeros and state multiplicity. And they give you the function f of x equals negative 7, x minus 5 quantity squared, x plus 1 to the 4th, x to the 3rd. So what we want to do on that is set each factor equal to 0, and realizing that these numbers on the outside are going to be our multiplicity numbers. All right, we don't have to do anything with the negative 7 because there's no x on it. There's no x, I don't have to do anything with that particular factor. This x minus 5, I need to set equal to 0. That will give me x is equal to 5. X plus 1, I need to set equal to 0. That gives me x equals negative 1. And x I need to set equal to 0. That gives me x equals 0. Then I go back in and do the multiplicities. This is going to be multiplicity 2 from that exponent. This one's going to be multiplicity 4 from that exponent. This one's going to be multiplicity 3 from that exponent up there. So then, it's a little bit hard the way they do it, so I'm going to show you how they write it out. It says the 0, 5 has multiplicity blank. So we have to fill that in. So we do have a 5, that's our 0. What will we put in the blank?
2.
2. Then it has a blank here that says, is a 0 of multiplicity 4? So what would I put there?
-1.
-1. And in the third blank, it says the remaining remaining 0 is blank.
0.
0. It has multiplicity blank. What goes there?
3.
3.
3.
Okay. That's the way the answers will need to be put in there. There's little blanks for you to put them in. Any question on that? Okay. Let's do number 5. Number 5 is going to be one that you can graph on your calculator. So don't make it harder than it needs to be. It says find the zeros and multiplicities. And it gives you f of x equals x cubed minus 2x squared minus x plus 2. So this one right here, that leading exponent tells me it's going to have 3 zeros. Or it could have 1 0 of multiplicity 2 and 1 of multiplicity 1. But it's going to have 3 when I get through with it. It's going to have some kind of form of 3. So let's look at it. And what you want to do is grab your calculator, since they don't give you any zeros, or you could use synthetic division. They don't give you any. So grab your calculator and put it in your calculator and see what you get. X cubed minus 2x squared minus x plus 2. And I'm going to graph that, and it sure looks like it's crossing. It's doing this kind of thing. Looks like it's crossing in 3 places. So if I can find my zeros, I'll be good. So do second in table. And I see, if I look down my second in table, I can see that I'm looking for 0 on the y, not on the x. I can see that at -1, there is a 0. And I can see at 1, there is a 0.
Yeah.
And I can see at 2, there's a 0. Do you see those? All right. So I don't have to do any more work. There's 3 zeros, so they're all multiplicity of 1. Notice how the graph goes through at those points, crosses across. So I already have them. So don't try to do synthetic. Don't try to break it down to quadratic and use the quadratic formula. You've got your 3 zeros right there. X equals -1, x equals 1, x equals 2. So fill in the blank then. The zeros are, and it says x equal, and the blank is out here. And it says put commas between your answers. So you would write -1, comma, 1, comma, 2, comma. Then on the second one, it says each 0 has multiplicity blank. What would you put in that blank?
1.
3.
If you put 3, that means that would be -1 to the 3rd power, 1 to the 3rd power, and 2 to the 3rd power. It's 3 altogether. This is the total multiplicity.
So to the first power.
To the first, yes. Each one would be to the first. To the, yes. Each one would be. Okay. Any questions on that?
My graph is the opposite of yours, and I can't figure out why.
I don't know. What did you put in x cubed or negative x cubed?
X cubed minus 2x squared minus x plus 2.
It goes this way.
I'll show you.
Where are you?
Can you see that?
It does go that way. What did you put?
Show us what you put in the y equals.
Yeah, show the y.
Oh, it is backwards. I got it. It's right.
Oh, okay. What was it?
The one that you have written at the top above the little X and Y box.
Uh-huh.
Mine's the opposite of that. That's what I was talking about. The one you just drew is correct. That one is correct.
No, it shouldn't be. It should be this one.
Okay, here's y equals.
Negative. What's your y equals look like?
Hold on, let me get the cursor out of the way.
Well, there's got to be a negative on it somewhere to make it do that.
I don't know.
There's not.
Hit the graph button again.
Do what?
Hit the graph button.
I think it's flipping it backwards for y'all to see it.
Oh, because
I
the
got,
screen is flipping it backwards.
Yes, I think the camera's flipping it to where it looks correct to y'all.
Okay.
No, that's flipping it to where it looks incorrect.
Now
Okay.
that looks.
I got it. I got the same thing you got, Miss Sullivan.
You got the same thing I got.
Hmm?
Okay.
Mine looks exactly like yours.
Yours looks like this one.
Yep.
Okay, Brooke. Go to your clear.
Okay.
Go to your clear and put it back in there.
I was just gonna say you could fully clear the calculator, hit second plus 712, and then try it again.
Okay.
Anybody else get an incorrect graph? That's going to be a problem if you don't get it straightened out.
That corrected it. I don't know why, but now it's correct.
Okay.
And it has the exact same thing in it that it had before. Okay. Sorry, guys.
Okay. What was that little trick you said to do? Who was that?
If you want to fully clear your calculator, all the memory you've had in like the day, you hit second plus 712.
Second plus 712 is clears the memory from today. Just from today.
Just like the whole before, like it just clears everything.
Okay. All right. So if you get stuck, guys, that's a good little hint. I didn't know that. How'd you know that, Luke?
Just a math magician.
Okay, we're all on board now. Let's do number 6. Number 6. Determine whether it's true or false. So this one should not take you long. If P of X, in fact, put a star on number 6. It's easy. P of X equals X minus 2 to the 8th times X plus 4 to the 3rd. Then, this is a statement, then the graph crosses, that's your key word right there, crosses the X axis at 2, 0. Okay, 2, 0 is definitely a 0. There it is right there. If I do that, X minus 2 equal to 0, I get X equals 2. So 2 is a 0, but does it cross at 2 or does it just touch it at 2? So these are your choices. You have true because X minus 2 to the 8th power is a factor, and the exponent is odd. Okay. X minus 2 is a factor, that's for sure. Is our exponent on it odd? What is our exponent?
It's
Even.
even.
It's even, so that one can't be it. Look at B. Is it false? Because x minus 2 to the 8th is a factor, and the exponent is even. Well, it is a factor, and the exponent is even. Is this a false statement? What happens when it's an even power? Does it cross it or does it touch it at an even power?
Touches.
It touches. It touches if an even power, not crosses. Touches is called tangent. They'll use the word tangent. So this is the answer that we want. That's a false statement because they're talking about this one right here, and it's not going to cross because if it's an even power, it's just going to touch it and bounce off. Let's look at the other two options so you can see what they're going to do. They say false because x minus 2 to the 8th is a factor, and the exponent is odd. So you see that part right there? Exponent's odd. That makes that not one that we want to pick. That exponent's not odd. And D says it's true. Well, you know it's not true because it doesn't cross it. But it says because x minus 2 to the 8th is a factor, the graph crosses the x-axis at 0, 2. So you see it doesn't cross, it just touches it. It's just tangent to it. So the one that we want that's most correct is this B. It's not this one because it's not an odd. It's not this one because it doesn't cross. So don't get confused on that easy question. If it's an even power, it's going to be tangent, not crossing. What if they said this one? What if they were talking about this one and said that -4 is a factor, is a 0, and it crosses? Would that be true?
Crosses at 2 or crosses at 4 and 0?
Crosses at 4 and 0. Would that be true?
Yes.
Yes. If they said -4, 0 there instead of 2, 0, would that be true? Yes. Because that's an odd power. Odd powers, they cross. Even powers, they bounce off. And if all else fails, what can you do?
Graph it.
Graph it. See if it's going through it, intersecting it, or if it's just touching it and bouncing off it. Okay, let's do number 7. How are we doing so far? Can you make 100 on it so far?
Yes.
Good.
Yes,
All right,
until we
so-
get to 4 questions.
This one is an easy one, so make sure that you do 6 and 7 really quickly. Find the maximum real zeros, the maximum x-intercepts, and the maximum turning points. And you get f of x equals -8x minus x cubed. And remember, you've got to lose, you might want to turn this around. You got to use your leading term to do this. Okay, so it says f of x has a maximum of blank real zeros. So what would that number be?
3.
Whatever your highest exponent is your maximum number of real zeros. What do you know about real zeros and x-intercepts? What do you know about those?
They're the same.
They're the same. Real zeros is equal to x-intercept. So the next one says f of x has a maximum of blank x-intercepts. So what would you put in there?
3.
Mm-hmm. And what do you know about turning points?
It's
They're
one.
one less.
Is one less. One less. So f of x has a maximum of blank turning points. How many would you put there?
2.
2. Okay. So whatever your highest exponent is, it's that one, and then this is one less. So don't make it hard. Just go in and do that one. And just know that the maximum is how many, whatever your leading exponent is. Okay, number 8. So now we're still at 100.
Yes.
Okay, sketch the graph. And it's h of x. You have an x out here, an x minus 3, an x plus 4, and an x minus 4. That's your problem. And you can put it in your calculator. And while you're at it, you could do your degree. If it's x times x times x times x, what are we going to end up with? X to the what?
Q.
X to the third.
X, there's 1, there's 1,
X to the 4th.
there's 1, and there's 1. How many is that?
4.
4th. That's going to be an x to the 4th. So our ending part of this is going to be both up because it's even there. You can kind of do that in your head and it will eliminate some of your answers. So let's see, we have an x equals 0 is one of the zeros. X minus 3 equals to 0 gives you x equals to 3. X plus 4 equal to 0 gives you x equals negative 4 is one of the zeros. And x minus 4 equal to 0 gives you a 0 at x equals 4. So you've got 1, 2, 3, 4. 4 of them. Okay. So let's see. With just knowing what you know, let me sketch the graph of these and see if you could tell which one it is.
Will this like little study guide be on the Blackboard as well?
Yes, it's already up there.
Okay.
All right. Just knowing what you know, can you tell which one the answer is?
C.
C.
Well, we have B or C. Which one do you think it is?
C.
The ends, if it's even, the ends have to both go up or both go down. So it's not going to be this one because it's one up and one down. It's not going to be this one because it's one up and one down. So your choices are C or D. And since it's even and the coefficient's even, it's a 1, is it going to be C or D?
C.
Well,
C.
so see how you don't even have to go in there and look at these little zeros. Just from the shape of number 8, you'll be able to tell the answer. And of course, you can put it on your calculator just like it's written here. Somebody needs to try to do that and see if you can get it in your calculator just like it's written there and see what it looks like. I'll do it.
I did. It looks like C.
It does look like C. Okay, good. All right, so that one's a go. We can do that one. Let's look at number 9. Number 9 says graph, and it's f of x equals 10x cubed minus 8x squared minus 90x plus 72. Well, it looks like our leading term is a cubic, and it's positive, so it's got to do something like that. The end of it is certainly going to be 1 up and 1 down. All right, so let's see what we could do. We could probably just figure out from there. Let me see if we've got any. Yeah, there's a couple that we might have to choose from. So let's go ahead and see how we would work this. It's got 4 terms, so let's see what we can do with that. If you take out a 2x squared, you'd have a 5x minus 4 from that first one. And if you take out an 18, because 18, you would give 5 times 18 is 90. 5x, and I took out a negative because the third term was negative, minus 4. That's the same. That's that little magic thing we do. So we have a 5x minus 4 and a 2x squared minus 18. Okay. We can set each of those equal to 0, even though it's squared. I bet I can mess with that. Let's do 5x minus 4 is equal to 0. Let's see where these zeros are. 5x is equal to 4. X equals 4/5. So it's going to cross the x-axis at 4/5. Let's see what this one's going to give us. 2x squared minus 18 equals 0. Let's add this 18 to both sides since I don't have an x term. Divide out my 2. I get x squared equals to 9. So x equals plus or minus the square root of 9. So x is equal to plus or minus 3. So I have my 3 zeros here. See, it's a cubic. One of them's 3, one of them's negative 3, and one of them's 4/5. So that's where they have to cross. Okay, so let's see what the graphs look like. Let me scoot this up and I'll draw the graphs. The A looks like this. And it goes up through there, back down through there, and back up through there. B comes 1, 2, 3, 1, 2, 3, comes down through there, back up through there, and down through there. C looks like this. And D looks like this. 1, 2, 3. 1, 2, 3. It looks like this. Okay, so can you tell me? We can eliminate this one, can't we? Because it's an even power and we've got an odd. So that one's totally eliminated. What's wrong with B?
not enough point.
Well, it's got 3 points. 1, 2, 3. Looks like the right points too. This is -3, and this is 3, and that could be 4/5 easily.
Should have came from the bottom.
Because it what?
It should have came from the bottom.
It should have come this way. So maybe
Yeah.
this is the answer. It's crossing through -3. It's crossing through +3. And this could be 4/5, couldn't it? So A is going to be your answer. What's wrong with this one down here?
It's like -2.5.
Mhm. It's crossing at like -2.5, and that's not one of your zeros. So A has to be your answer. This one's backwards. It would be a negative. It's backwards. And this one's the wrong zeros. Okay. So hopefully it won't take you long to do that one. So are we still at 100 for most of you? Everybody can do these?
Yes.
Okay, good deal. All right, now we're at the section with use synthetic division. This is number 10. Gosh, we're getting through this. Use synthetic division to determine the numbers are whether the numbers are zeros. I have to read this right. Whether the numbers are zeros. So we're using synthetic division to determine whether the numbers they give us are zero. And this is the way they write it. They write -1 and a comma and a 1, then a semicolon, and they write out their function after that. And you have an x to the 4, so there would be 4 zeros, or at least a multiplicity, a total of 4. And 3x cubed plus 2x squared minus 7x plus 1. And it says to use synthetic division. Now the question is, if they're
Let's say
written
2x squared. I'm sorry.
2x squared, yes.
Okay, thank you.
The question is, do we change our signs that go in the box or not? Somebody tell me.
With division, no, right?
No, you don't. If it said x equals or x minus, if it said x minus something, then you'd have to change it because you'd have to solve it for x equals. But these already are the zeros. They think these are zeros. So you don't change the signs. Write yourself a note. Do not change the signs. Because sometimes you do. If it's in the x minus form, you would change them. I don't know if you even have any of those or not. So we do our coefficients then. 1x to the 4th, 3x to the 3rd, 2x to the 2nd, -7x, and 1. And remember, if there's one missing, if the cube had not been there, we would have to put a 0 in its spot. Okay, so bring down the 1. You don't change signs. You should like this a whole lot better than that long division we did. So you multiply -1 times 1 and put the answer here. 3 and a -1 is 2. You're combining like terms. 2 is positive. -1 times 2 is -2. So you get a 0 in that spot. -1 times 0 is 0. So you have 0 and a -7 is -7. And -1 times -7 is +7. So it looks like we get an 8. So what would we say? Is that -1 a 0 or not?
No.
It's not, because you got to get what in that spot?
0.
You got to get a 0. So let's try our 1. See if the 1's going to be 1. 1, and it's possible that neither one of them will be. Okay. Bring it down. 1. 1 times 1 is 1. 3 plus 1 is 4. 1 times 4 is 4. 4 plus 2 is 6. 6 times 1 is 6. -7 and 6 is -1. -1, and guess what? That one is a 0. So with that one, you write yes. Okay? Well, how else could you do this problem besides using the synthetic?
Can you graph it and see if there's, can you graph it and look and see if there's zeros on
That's
the calculator?
correct. That's exactly right. Very good. You can just go down and find -1 and see, you know what you're going to see over there? You're going to see an 8. That's not a 0. But then if you go to +1, the y is going to be equal to 0. So that is a 0. You're right. You can just put it on your graphing calculator and check your table.
I don't know why I always get excited when I see that there's a 0 there.
Oh, me too. Me too. Oh, yes. It is a 0. I'm so excited. All right, let's look at number 11. Number 11 says find a polynomial function of degree 4 with, and this is going to describe it, -4 as a 0 of multiplicity 3 and 0 as a 0 of multiplicity 1. So our little rule for this, and I think I'm going to do it all the way. I'm going to say that means that x equals -4 and x equals 0. That's what that means. So if you want to put it in factored form, because you have to put them as little factors to multiply them out, then what you're going to do is add this to both sides, and you would have x plus 4 is a 0. Add that 0 to both sides, and you'll have an x plus 0 equals 0. So there's your factors right there. Or you can remember that you do the shortcut. We talked about that. The shortcut is x minus the 0. In our case, it would be x minus a -4 and x minus 0. And this one become x plus 4 and x minus 0. Either if you do the shortcut or you do the long way, you're going to have factors of x plus 4 and x minus 0 or x plus 0. Either way, it didn't matter on 0. X minus 0, in fact, we could just leave it. We can change that one to just plain x. Because if I subtract 0, I still get x. Okay, let's see if we can figure it out. Our f of x is going to be x plus 4, and on that one, our multiplicity is 3. So I need to put a little 3 up here as my exponent. Then I have x, and its multiplicity is 1. So that's kind of what I have. If I can just figure out how to multiply it out, I'll be in good shape. This is really x plus 4 times x plus 4 times x plus 4. That's what x plus 4 to the third is. Then I have this x out here. Okay, now there's all kinds of ways you can do to multiply this. I think that what I'm going to do is multiply these two and multiply these two. See what I get. So if I multiply those first two, I get x squared plus 4x plus 4x plus 16. Now if I multiply these two, I'm going to distribute that x, and I get x squared plus 4x. Okay, this is going to simplify to x squared plus 8x plus 16 times x squared plus 4x. Now, I hope you can remember how to multiply a trinomial times a binomial. You just take this x squared and you multiply it by everything that's over here. When you get through, take the 8, multiply it by everything. Then you multiply the 16 by everything. That's what you're going to do. You're distributing it. So the first time is x squared times x squared. That's x to the 4th. Then I'm going to do x squared times 4x. That's 4x to the 3rd. Then I'm going to do my 8x times my x squared. That's 8x to the 3rd. Then I'm going to do my 8x times my 4x, and that's going to be 32x squared. Now I've done everything but my 16. I have to do my 16 times everything. So 16 times x squared is 16x squared, and 16 times 4x is 64x. So I think I've done everything I need to do, except I need to combine terms that look alike. So I've got a couple of cubed terms there and a couple of squared terms there. So I have x to the 4th plus 12x to the 3rd plus 48x to the 2nd plus 64x. Okay, that's going to be my answer right there. Any questions on that? You could have multiplied these two, gotten your answer, multiplied it by this one, gotten your answer, and then multiplied it by x if you want. But I think it saves a little bit of time if you'll do 2 of them at a time. Any questions? We good? Okay. Let's try number 12. Number 12. Okay, so you have a polynomial function of degree 4. And it's going to say with rational coefficients, they have to say that because of the theorem. It says it has the following zeros. Find the other zeros. Now, don't make this one too hard. It's only asking you to find the zeros. It's not asking you to find the polynomial like the last one did. It started out, find the polynomial of degree 4. This one says find the other zeros. So be careful on this. It doesn't ask for the polynomial, just the zeros. And it gives us 2 of them. So that's 2 out of the 4. There should be 2 more. What would the other 2 be?
Maybe the opposite of those?
Say again?
Would they be the opposite?
Not the opposite. They're called, what's that special word?
Inverse?
Reciprocals.
Conjugate.
Oh, conjunction.
Conjugates. Why aren't they called opposites? Anybody know? Because if they were opposites, this sign in this front of this 4 would have to be changed. It's only changing the sign in between the 2 numbers. You can't really see it here, but it's here it's easy to see. It's only the sign between the 2 numbers that changes, not the first one. So they're called conjugates. So what would go in this blank, you think?
Aye.
I. And how about this one?
4 plus the square root of 5.
Now, that's probably the easiest problem in the test. This is the easiest. Can't spell easiest. Okay, so make sure that you do that number 12 and don't miss it. Any questions on it? Okay. All right. Don't let that number 12 scare you. Just do it. Just write the questions down really quick and write the answers down. Write the answer down really quick and you'll have it. Okay, this one does say find a polynomial function. That's what this one says. So that means we're going to be multiplying these things out. It says of lowest degree. With rational coefficients that has the given numbers as sum of the zeros. Sum of the zeros. All right, they give us the square root of 3 and they give us 5i. So we know it doesn't give us any rational ones, it just gives us those two. So we know that there are two more. What are the other two?
Negative 5i and negative square root of 3.
Whatever you have here, do the negative of it. Whatever you have here, do the negative of it. And you can't really tell those are conjugates, but they are. There's like a 0 in front of them. But they're called conjugate pairs. They always come in that. Remember when you do that square root problem where you take the square root of both sides, you always get plus or minus the square root? That's why. That's because there always have to be conjugate pairs. All right, so let's do x minus the root, or the 0. I keep calling it root. This author doesn't use that word. X minus the 0. So we're going to do x minus the square root of 3. X minus a negative square root of 3. I'm going to put it with that one. X minus 5i. X minus a negative 5i. So it's x minus the 0. Any questions on that? That's your rule for getting the polynomial. Okay, let's clean it up a bit. X minus the square root of 3, x plus the square root of 3, x minus 5i, and x plus 5i. Now, you'd be really not smart to multiply these two in the middle together. You want to get rid of the i's and get rid of the square roots. Okay? All right, let's see what we've got here. So x times x is x squared. X times the square root of 3 is x square roots of 3. X times the negative square root of 3 is negative x square roots of 3. And square root of 3 times square root of 3, it's a negative in front of it, is the square root of 9. So there's that one. I don't like this pen either. I'm having a pen problem. Over here we have x times x is x squared. X times 5i is 5xi. X times negative 5i is negative 5xi. And negative 5i times positive 5i is negative 25i squared. Ding, ding, ding. I hope bells went off in your head when I put that I squared down. So we need to know a couple of things. We need to know that I squared is equal to something. What is I squared equal to?
-1.
Good job. And what is the square root of 9? Because I need to simplify that one too.
3.
3. Okay, so I'm going to substitute in those values here and clean these up. So I have x squared. These two things will cancel. I have minus the square root of 9, so that's minus 3. And over here, we have x squared, and the 2 in the middle cancels, so we don't have any i's. This becomes -1. So I have -25 times -1, which is +25. Okay, now that I'm ready to multiply these, I get x to the 4th plus 25x squared minus 3x squared minus 75. So I think these two in the middle will combine, and I'll end up with x to the 4th plus 22x to the 2nd minus 75. Okay, so what do you think about that one?
I feel fine about that one.
Okay, how about you, Amanda? Can you do that one?
Yes, ma'am.
Good. How about you, Brooke?
I can.
Okay, Margaret, you good? Are you doing okay, Margaret?
It's long, but yes, ma'am.
Okay. You just have to be careful. And know on this number 13, just write yourself a note that the square roots should cancel. And the I should cancel. So if you get down there and they aren't canceling on that number 13, then you've got an error somewhere. Okay. All right, let's look at number 14. It says the polynomial function f of x has the given zero. Find the other zeros. See, it didn't ask for the polynomial. It asked to find the other zeros. So you have f of x equals x cubed plus 5x squared minus 6x minus 30. Then they have this little semicolon with a -5 out here. That's telling you the other roots. One of the roots is -5. Now, -5 is not going to have a conjugate because it's a rational number. It's only when there's square roots or i's that it has a conjugate. So I can't assume that the +5 is going to be an answer because this is rational. It doesn't come in conjugate pairs, only those with i's and square roots. But I can use synthetic division and break this down and see if I can find another, break it down to quadratic, and I can factor it or use the quadratic formula. So 1x to the 3rd, 5x to the 2nd, minus 6, minus 30. So I have -5, and this is a 0 here. That's good. It's a 0 and a -6. That's a 30, and this better be a 0, or that's not a 0 of the function. So remember, I started with an x to the cubed. When I do this process, it breaks and reduces my polynomial function down 1 degree. So if this started x cubed, then this one's going to be x squared. So I have 1x squared, 0 x's, minus 6, and now I can solve this easily by using the square root rule. Plus or minus the square root of 6, and there's not any perfect squares in 6. So there's a blank that says the other zeros are blank. Square root of 6, negative square root of 6. Okay, any questions about that? Good.
Yes, ma'am.
Okay. Let's do number 15. Number 15 says list all possible rational roots. Zeros. Sorry. This is the rational root theorem of the function. So you have f of x equals 16x to the 6th plus 15x to the 3rd minus 14x to the 2nd plus 7x plus 5. Okay? Now then, when it says looks all the possible rational roots, think P over Q. That's what you're going to think. P over Q. And the 5 that's here is your P, and the 16 is your Q for these. So you write down P is equal to 5. Factors of 5 are numbers that will go into 5. 1 and 5. That's it, right? But you've got to remember it's plus or minus those. Last time I put a plus or minus in the front and just put them in parentheses. So the Q is going to be the 16. So you need the factors of 16. So we know it's plus or minus 1, plus or minus 2. 3 won't work. 4 will. Plus or minus 4. 5 won't work. 6 won't work. 7 won't work. 8 will work. Plus or minus 8. And then I've got 8 and 2, 4 and 4, 1 and 16. So then what I do is put the P over the Q. So I have plus or minus 1 over 1, which is 1, plus or minus 1 over 2, plus or minus 1 over 4, plus or minus 1 over 8, plus or minus 1 over 16. Then I've got to do the 5.
You can't do this homework. It's mine. It's my homework. You did your homework already.
Body's not muted. Okay, what plus or minus 5 over 1, plus or minus 5 over 2, plus or minus 5 over 4, plus or minus 5 over 8, plus or minus 5 over 16. Now, the only thing that is hard about this is remembering which one is P and which one is Q. I'm not sure that I know a good way to remember that. Anybody have a good way to remember that the last one is your P and the first one is your Q? Because they're going to for sure give you an answer of the Q over P choices instead of
Is
P.
the constant always the P?
Yes, the constant is always the P.
And then the leading term is always Q.
The leading coefficient is always the Q. I don't know unless you remember it's opposite the alphabet. I really don't have a handy dandy way to remember that. But that'll be the only thing you have trouble with on this one is remembering which one's P and which one's Q. This last one is P. This first one is Q. And it's always P over Q. Watch your P's and Q's. Okay, any questions on that one? Okay, let's go to the next one. This number 16, you need to put a star on. It is tricky. Number 16 is going to be a tricky problem. Let's look at it. Number 16 is find the rational zeros and then the other zeros. And here's your polynomial, 2x cubed plus 3x squared plus 18x plus 27. Then they want us to factor into linear pairs. Factor into linear factors. Okay. All right. So let's see. It's got 4 terms, and they're not going to have us do a whole lot of hard problems at this point. We have too much to do with them. So let's see what we're going to get here. We can take out an x squared, and we'll have a 2x plus 3. Can we get a 2x plus 3 out of this? I think if we take out a 9, we would have a 2x plus 3. So it looks like we have a 2x plus 3 times x squared plus 9. So let's set those equal to 0. We have a 2x plus 3 equal to 0. And that gives us 2x equals negative 3. That's x equals negative 3 halves. And that particular one is rational. It's a rational 0. Okay, let's try this other one. X squared plus 9 equals 0. Uh-oh, looks like this one's going to be not rational because I have to take the square root of negative 9. So x equals plus or minus the square root of negative 9. Okay, does anybody remember what I'm going to run into here?
You have to pull out the negative to I.
That's right. We have to remember that the square root of negative 1 is really I. So I have plus or minus the square root of negative 1 times 9. Then I can say that's plus or minus the square root of negative 1 times the square root of 9. And that's plus or minus I times 3. And if I want to make it really nice, I'll make it 3I. So these are other zeros. Okay. So then I've got to factor it into linear factors. Okay. Now this is where you have to be careful right here. This one right here is already a linear factor. It's how I got this negative 3 halves. This one is not a linear factor. It's a square. But I can go ahead and save myself some grief by trying to figure out where the 2 came from if I just use that one as one of the linear pairs. I can do that. So I can say that is 2x plus 3 is one of them. We'll show you another way to write it that the author should take it. Then I have to do x minus these others. X minus 3i and x minus a negative 3i. So this would give us 2x plus 3 times x minus 3i times x plus 3i. Now, another thing, another way to write this, this is a good answer, and the author should count it. Those are all linear factors. If you want to do it from this point right here, you can. You can say x minus this root, x minus a negative 3/2. Then you'll have the x minus 3i and the x plus 3i. And this is going to be x plus 3/2. Now see, these are different. This is a different factor than this one up here because this one had the 2 in it. But I need the 2 to go in front to make my original problem. So what I have to do if I put it in this form is to put my 2 out here in the front. And then when I multiply this, do you see I get the 2x plus 3? And I still have preserved my 2 that's in my original problem. So there's 2 ways you can write it. Either way should count. You can write it with the 2x plus 3 that's right here that you factored out because it is a linear factor and it does have the 2 in it. Or you can go from here and do x minus that, 0, but you've got to remember you've got to have a 2 for this polynomial. So you have to put the 2 out here, and that's how that gets to be 2x plus 3. It has to check so that when you multiply it back, you can get this polynomial. That's a trick. That's a tricky thing right there. Be careful. Do I have any questions about that? No questions? Y'all just taking my word for it, aren't you? Okay. Let's do number 17. We're almost through. Well, no, because we got some big ones coming up here. 17. 17 is find the domain. Now, according to our poll tonight, you can do domains. I hope that's true. I hope we get 100% on this question. The numerator on this problem is x cubed minus x squared plus x plus 1. The denominator is x squared plus 9x plus 8. So all you have to do is factor the denominator, because you're wanting the domain. And some of you that have worked ahead and you got all that 8.6 done knows there's things like zeros, that's holes in the graph, that's going to happen. But a hole in the graph is an undefined place anyway. So you don't have to worry about factoring this and canceling these out on this problem. It doesn't matter if it cancels out or not. It's still an undefined place. So just worry with your denominator. X squared plus 9x plus 8, and set that thing not equal to 0 because the denominator of a fraction cannot equal to 0. Right, let's see if we can factor this. X and x. I got to add factors of 8 to get 9. What would that be?
1 and 8.
1 and 8. Y'all are good at this factoring.
Plus 8 minus 1.
They both got to be plus to add, or both minus. All right, so x plus 1 equal to 0 gives you x not equal to 0. X cannot equal -1. X plus 8 not equal to 0. X cannot equal to -8 either. All right, they want to do set builder in this one. Set builder notation. So let's see. Let me tell you the answers to these and see if you can figure it out. X such that X is a real number. And that's all it says. Would that be the answer?
No.
No, why not?
Because it doesn't mention what it can equal.
Right. It doesn't have the undefined value. Doesn't have the undefined values. Okay, the B part, and you have to be careful here. On the B part, it says X such that X is a real number. And X does not equal, and it has a blank here. And you're so used to putting in -1, -8 that some of you are going to pick this one if you're not careful and put that in the blank. But look at C. C is a choice that's going to have X such that X is a real number and X does not equal blank and X does not equal blank. See, if you weren't paying attention, you would pick this one and put the two values in. But C actually has a blank for the two values. But you also have to be careful right here because it says use ascending order. Ascending means it's going up. So this is the one that I want to pick right here because it's got two values for me to put in. Which one do I put in first if I want to do ascending order?
-8.
And then you put in a -1. So be careful on this number 17 to read all of the answers. Then the second part of this one is they want you to also go ahead and do interval notation. And they give you a big long line and you're supposed to put in interval notation. So -8 is first, so I would do -infinity up to -8, parentheses, oops, I did a sideways 8 there. And then we go from -8 to -1, and then we go from -1 to positive infinity. I think you can do the interval notation. Am I going too fast? Or are we okay?
Okay.
Okay, let's do number 18. Number 18, this is find the domain. And you have f of x equals -1 over x squared minus 2x minus 35. So again, we do the same thing. We do x squared minus 2x minus 35 not equal to 0. Factor this. I think this factors into x minus 7, x plus 5. So x minus 7 not equal to 0 gives us x not equal to 7. X plus 5 not equal to 0 gives us x not equal to -5. Okay? And they only want it in interval notation. So you're okay on this one. It goes from negative infinity to negative 5, union negative 5 to 7, union 7 to positive infinity. So this one's an easy problem. You can do that one really fast, number 18. Any questions? Okay, let's look at 19. 19 is one of those long ones that has multiple parts. And so spend your time doing all the ones that aren't long like this. Write the word long on top of 19 because it's long. List all asymptotes and graph. Okay, our function is r of x equals 2 over x squared minus 25. So we don't have to worry about domain. We're going straight to asymptotes. Vertical asymptotes, you set the denominator equal to 0. So you have x squared minus 25 equals to 0. That's x plus 5 and x minus 5, or you could take the square root of 25. So you have x plus 5 equal to 0. Gives you x equals negative 5. And x equals positive 5. Those are your two vertical asymptotes. Okay? Now be careful on those. It says type equations on this problem. So you'll have to put in the x equals negative 5 and x equals 5. Okay, they ask for oblique for the next one. So let's check this out. We have 2 over x squared minus 25. And what you want to do on this is make that 2x to the 0. Add that x to the 0 on the top. In the bottom, we have x squared minus 25. So the m is 0 and the n is 2. So m is less than n. If m is less than n, it has a horizontal one. That means it does not have an oblique one. So this one has a horizontal one. And the next thing we'll find the horizontal one.
They were trying to hit me with that. Whenever it's
There's
cold.
no oblique.
A what? Cat boy?
Layla, is that you?
Ow. Hello.
Not this time.
Oh, it's not you. Somebody else has a passel of kids, huh? So the horizontal asymptote is the one we need to use. So use your rule list. What does the rule list say if m is less than n? What is your horizontal asymptote?
Y equals 0.
Y equals 0. There's your horizontal asymptote. Good job. Then you have to find the graph. And they're very different graphs. A looks like this. Graphs go out this way and underneath here. That's A. B has a little asymptote over here, and the graph goes here and here. C, there's that same horizontal asymptote, and the graph goes here and here. And D looks like this picture, except it's opposite, has two vertical asymptotes, and the graph looks like here and here. And if I were you, I would just put it on my calculator and see which one it is. But you know it's going to be, the vertical asymptotes here are 5 and negative 5. So it can't be this one because it only has one vertical asymptote. It's either got to be this picture or this picture. So I would grab my calculator and graph it and see which one it is. To put this in your
D.
you think it's what? D? Let's see.
I think it's D.
2 divided by parentheses x squared minus 25. Let's see. I'm going to change my zoom, my window to something smaller. Let's see, it's 5 and negative 5. So 10 and 10 ought to work on that. It's the y's that's going to be a problem. Negative 5, 5. Let's see if that'll help us get a better picture. Yeah, looks like it's the one on the first one there. Do you see it? Looks like this one's going up this way. This is fat in the middle and goes this way. So it looks like it's A.
But so we didn't zoom out enough to see the one on the bottom, but we just looked for the negative 5, 5, right?
Yes, you've got to have those, but both of these had those. You've got to know where
Okay.
the middle part is, and it looks like the middle part is below here. See, the middle part goes down instead of going up.
Okay.
The middle part on this one's going up.
I didn't see part.
All right. Let's try number 20. So 19's long because you have to find all the asymptotes on it. And it's not going to be oblique because I can tell you they're not going to give you one that's oblique. If they do, I'll give you the point back. They don't want you to spend all that time doing that long division. So this one is determine the vertical asymptotes. So you have g of x equals x cubed on the top, and you have 2x cubed minus x squared minus 10x. And again, just like I said before, you don't have to worry about getting rid of those the thing on the top. So let's see what we've got here. Well, maybe you do on this one because this one's going to have a factor that comes out here. 2x squared minus x minus 10 if you do that. And one of these is going to cancel into one of those. So you end up with an x squared on the top when that cancels out. So that means there's a hole at x equals to 0, because if you set this factor equal to 0, there would be a hole. So only worry about this part for vertical asymptotes. These will be your vertical asymptotes. The other thing is a hole, because it canceled. Anytime they cancel, there's a hole. So if it cancels out, don't worry about if it's a vertical asymptote or not, because it's not. It's a hole instead. Can't be both. So now we have 2x squared minus x minus 10 equal to 0. Looks like that's an AC trinomial. 2 times 10 is 20. I have to subtract factors of 20 to get 1. Is that 4 and 5? I want my 5 to be negative, right?
Yes.
So I have 2x squared plus 4x minus 5x minus 10. Bringing down the first term, renaming those middle terms. Did I factor 2 and 2? Take out a 2x and I'll have an x plus 2. Take out a negative 5 and I'll have an x plus 2. The negative will change that sign. So I have an x plus 2, that's my common one, and 2x minus 5 is the other one. So if I set each of those equal to 0, that will get the asymptotes. X equals negative 2, 2x minus 5 equals 0, 2x equals 5, x equals 5 halves. Okay, Now this one has x equals blank. Remember that last one that said use an equation? This one says use a comma to separate answers. Now I'll go back and catch these if you don't pick up on all these little individual ones. Instead of writing x equals -2, x equals 5/2, they want you to do it this way on this one. Okay, that's 20. Am I going too fast? Are you able to keep up? Okay, let's do 21. I can tell my Zyrtec has run out tonight. This time we want the horizontal asymptote. And we have f of x equals x squared minus 8 over 7x to the 4th plus 4. All right, so m is 2, n is 4, so m is less than n. So what is the horizontal asymptote? Anyone know?
0.
What is it? 0. Yes, y equals 0. Okay. Any questions on that? Okay. Let's do, the next one is a pretty long problem. It's going to ask you for the domain and the x and y intercepts and graph. So they give us f of x equals x squared plus 4x minus 5 over x squared plus 6x plus 5. We have to factor those. Anybody ahead of me? What do you factor this into?
X
X plus 5. Is that right?
and X minus
Okay. And in the bottom?
1. X plus 5, X plus 1.
Okay. For domain, you don't have to cancel. So domain, you use all of the original, not the canceled part. So we've got to do x plus 5 not equal to 0 and x plus 1 not equal to 0. Okay. So x cannot equal to -5 and x cannot equal to -1. They want the domain in interval notation. So it would be -infinity to -5, union -5 to -1, union -1 to positive infinity. Okay, now my advice to you is to see if there is a hole that may cause you trouble, and besides, you're going to have it to graph. And there is a hole right here. See that? X plus 5, if that is equal to 0, there's a hole where x is equal to -5. It's a hole. That's that canceled one. That's going to be a hole in the graph. It's not part, it's in our domain, it's not going to be there because it's a hole. That's why it's okay to use both of those. we need to find out what the value is there. So using the reduced function, put in x. So we have the y value. Let's just put y equals, let me put it down so you'll know what I'm using. That x minus 1 over the x plus 1. It's going to be negative 5 minus 1 over negative 5 plus 1, which is negative 6 over negative 4, which is positive 3/2. So there's a hole at negative 5 3/2. That's going to be important when we graph. It might be important when we find the x and y intercepts, but probably not since neither one's 0. If one of these had been 0, that's going to mess up my x and y intercepts. Okay, so the next thing to do is to find the x-intercept. So we're going to let y equal to 0. So if we have, let's use the reduced one for this one. So we're going to have y equals, and I'm going to write down this reduced one, x minus 1 over x plus 1. Put a 0 in for y. Multiply both sides by x plus 1 because that x plus 1 is in the denominator. So we have 0 equals x minus 1. X equals 1. So 1 comma 0 is the x-intercept. Now to do the y-intercept, let x equal to 0. Okay? That's what we're going to do. So y equals 0 minus 1 over 0 plus 1, which equals negative 1 over 1, which is equal to negative 1. So that's going to be the y-intercept is 0, negative 1. Anybody have a question about how you find the x or the y-intercepts? To find the x, you let y equal 0, and you can use the reduced form after you canceled out that common one. Any question on that? Okay. It did ask us to find the vertical asymptotes. I didn't write that down, but it did ask us to find that. The vertical asymptotes on this one. And you can use the reduced form. So you have f of x equals x minus 1 over x plus 1. X plus 1 is equal to 0, so subtracting 1 gives you x equals negative 1 is your vertical asymptote. Horizontal asymptote. On the horizontal asymptote, you need to use the original one because sometimes there's a sign change. So our original one was x squared plus 4x minus 5 over x squared plus 6x plus 5. So m is equal to 2. N is equal to 2. So m is equal to n. What do we do when m is equal to n?
Y equals A.
Y equals a over b. I think you guys got that. And a is up here, and b is down here. It's the coefficients of those leading terms. 1 over 1. So y equals 1 is the horizontal asymptote. If it has a horizontal, there is no oblique. Okay, let's see how these pictures are going to go. A has a picture that looks like this. At x equals -1, there is an asymptote. At y equals 1, there is an asymptote. It crosses at what were 1, 0 and 0, -1. And there's a hole in the graph. Where was our hole in the graph? At -5, 3/2. So A is going to be your answer. But let me tell you what the others look like. B has the hole in the graph over here, which keeps it from being the right one. See the holes over here? So the hole in the graph is the secret on knowing which graph this one is. This one has a hole in the graph, but the hole in the graph is down here, right there. And it looks like this, so it's not the right picture anyway. And D is the same thing, but it has a hole in the graph down here. So the hole in the graph was the whole reason to be able to figure out which graph it was in this one. So be careful on these graphs for this one. Check the hole for this one to be able to know which one is the right graph. Now that is your worst problem right there. I think it's harder than any of the others.
Yeah, on the homework, it took me some time to do a couple of these earlier today. It was like these same problems with the 4 or 5 items.
Uh-huh.
I think it was at 8.5, I think it was this section.
This is 22. 22 is very long. Okay. 23 is the same way. It's very long. If you can survive 22 and 23, then 24 and 25 aren't bad. Okay, it's after 8 o'clock. If you want to stay with me for this 23, 24, and 25, that's what I'm going to do. If you don't want to stay, it's okay. The class is over. So I understand if you want to drop off. But if you want to stay, that's where I'm going. 23 is find all those things, the domain, the x and y intercepts, the vertical asymptotes, the horizontal asymptotes, same thing. It's the very long ones. So we have x squared plus 3x over 4x cubed minus 11x squared minus 3x. Looks like this one's going to have a hole as well. This one will factor into x, and I'm going to go ahead and factor it for you so you'll know what it factors into. It factors into x times x plus 3 on the top, x times x minus 3, which means those factors are not going to cancel, and a 4x plus 1. I did work this out on the notes for you. Okay, so there's a hole at x equals to 0, because that's that factor right there. If I set it equal to 0, that thing is canceling, so there's a hole there. Now, that doesn't affect my domain. My domain means that there's hole that's going to be included there. But let's put the 0 in and see what the y value is of the hole. So I would have 0 plus 3 over 0 minus 3 and 4 times 0 plus 1. This is the y value of the hole, which gives me 3 over negative 3 times 1, which is 3 over negative 3, which is y equals negative 1. There's a hole at 0, negative 1. Now, that normally would be a y-intercept. So this means there is no y-intercept. Because you've got a hole there. See, 0, -1 would be down here. And normally that would be a y-intercept. But now that thing is a hole. So it's not going to have a y-intercept there. So when we come to y-intercept, there's not going to be one. Okay, let's go back to domain and look at domain. In domain, you use all of the bottom. So you're going to use x equal to 0, x minus 3 equal to 0, because that's a defined spot right there. And 4x plus 1 equal to 0. Use everything you've got in the denominator for your domain, not for your vertical asymptotes, but for your domain. So we have 1 at 3. Looks like we have 1 at -1/4. And they have this in set notation. It says x such that x cannot equal to 0 and x cannot equal to 3 and x cannot equal to -1/4. So we could have done not equals like we normally do on these to start with. So we did domain and we found the hole. Okay. Now then the next thing to do is the vertical asymptotes. This is where you don't use the one that is the hole. It's a hole. It's not a vertical asymptote. Still undefined there, but it's not an asymptote. So you're using x minus 3 and the 4x plus 1. Those two. From over here, we had an x minus 3 and a 4x minus 1. We set those equal to 0.
Like x, I'm trying to figure out the whole thing. So the whole is at x equals, because it's outside of the parentheses, is that?
No, it's because it canceled. If it cancels, if it has a term in the top, a factor in the top that it can cancel into, that makes a hole. If this had had an x plus 3 here, I would have canceled these and it would have had 2 holes.
Okay. Okay, I get
It's
it.
a hole because these canceled.
Okay.
Okay, that's kind of a hard concept. So now we have, for our vertical asymptote, x equals 3 and 4x equals -1. So x equals -1/4. Those are our 2 vertical asymptotes. Okay. Now then, the next thing we're going to ask for is horizontal asymptotes. And this one you use the original. On the horizontal, you always use the original problem. So our original problem way long ago was f of x equals x squared plus 3x over 4x cubed minus 11x squared minus 3x. So in the top, the m is equal to 2. The n is equal to 3. Those are the exponents for the leading terms. So M is less than N. So what is our horizontal asymptote?
Y equals 0.
You got that one down, don't you? Y equals 0. And then there is no oblique. If you have a horizontal, you will not have an oblique. Okay, let's do the x-intercept. The x-intercept, remember we let y equal to 0. And we can use the reduced one. So we have 0 equals x plus 3 over x minus 3 times 4x plus 1. And what you want to do is multiply both sides by this denominator. So you're going to have x minus 3 times 4x plus 1 times 0 on this side. And on this side, you're going to have an x minus 3 times 4x plus 1 in the bottom. In the top, you're going to multiply that x minus 3 and that 4x plus 1. Those two things are going to cancel. And then we just have that times 0 is 0. So it looks like x is equal to -3. So -3, 0 is the x-intercept. Now remember, at 0, -1, we have a hole. So that tells us because there's a hole there, there is no y-intercept. It is a hole. Okay? And that hole was at 0, -1. Okay, let me show you the pictures of this one. This one comes down this way and looks like this, and has a graph that comes this way and this way. But there is no hole. We know there's a hole at 0, -1, so it can't be this one. This one is a graph that has the line here and over here, and it comes down in the middle right here. But there is no hole, so it can't be this one. Okay? The C, this is A, this is B, this is C. C has a hole in the graph, but the hole in the graph is at 0, 1, not at 0, -1. So it comes down like this, and it comes this way and this way, but the hole in the graph is in the wrong place. Okay, so that means that if C doesn't work and B doesn't work and A doesn't work, then it has to be D. So let's see what the D picture looks like. The D picture has an asymptote over here, and it has an asymptote at, where's the other vertical asymptote? At 3. And then there is a horizontal asymptote at 0. Was it 0? Where was our horizontal asymptote?
Yes, ma'am.
At 0. And there's a hole in the graph at 0, -1. So the picture looks like this. And it goes out this way and out this way. So the D is the answer. And the hole is in the right place on this, and the picture's right. So you may have to graph it and then just check on your graph to see if it has an undefined place at 0, -1. But this is probably the toughest problem right here, because you had to really look to find out the right answer on that one. Okay, so we know that 22 and 23 are tough, but the rest of the test wasn't too bad. We're at 24, and this is solve the inequality. This is what we did for the homework, so hopefully it won't be hard. We know that this is a dashed boundary, and we know we want to have the area below the x-axis because it says less than. So we get our boundary by setting this equal to 0. So I have zeros at -3 and +2, and my boundary line is dashed, and I want to know what my interval notation is for this graph if I want the area that is below the x-axis. So I'm looking at this area right in here. So from what to what would be below the x-axis? This point over here is -3. This point is 2.
-3, 2.
And we use parentheses because it doesn't have the bar underneath there. Then on 25, it's just like it. We have x squared plus 18 is less than 8x. You want to move your 8x over by subtracting it from both sides. And now write down your information you want below the x-axis, and you want dashed. So you need to factor this if it'll factor. So let's see if we can factor this. X and X. I have to add factors of 18 to get 8. 6 and 3 is 9. 9 and 2 is 11. 18 and that won't work. This will not factor. Okay. So
There was one thing on homework, and I tried factoring it 4 times. And then I was like, ha, there's no solution.
So I'm going to grab my calculator and look at this to see what it looks like. Minus 8x plus 18. And when I graph this thing, I find out that this little thing is way up here. It doesn't cross the x-axis at all. So the answer is the empty set. There is no solution. No
Okay,
part.
so would there not be, I guess I got confused, like if you can't factor, you wouldn't use the quadratic equation on this one, would you?
Yes, you would, because you might
Okay.
have radicals.
Right,
And
okay.
radicals would be along here, like the square root of 2 and this, negative square root of 2. Those would be points of the graph. So it might be that you would use the quadratic formula. But the smart thing to do when you see that it's not going to factor is to grab
Just
your
put it back in.
calculator and see if perhaps it's not even crossing the x-axis. Because it has to cross the x-axis to have